So in 2.2, this is very similar to our study on radical functions where you have y equals square root of x, but we really only studied this function and how we transform square root of x. In 2.2, we take a look at square root of, so y equals square root of something else that's more than just x. So square root of another function like 2x or 5x squared plus 5 or something like that. So we're going to look at graphs that aren't just restricted to the square root of x, but we're going to look at transformed graphs and their roots. Okay? So this is very similar to 2.1. Let's say we have an equation y equals x plus 1. And we have another graph y equals square root of x plus 1. And what I'm going to do is I'm going to do a little table of values here. And yes, we'll graph them a little bit later, but let's just explore this. Okay. So, I'm going to try and pick x values that are going to be fairly friendly, all right? So what about 3? If I pick 3 here, y is going to be what? 3 plus 1 is 4. Okay. So if I pick 8 over here, this is going to be 9, right? And if I pick 15 over here, y is going to be 16, right? Okay, so let's pop over to this one. If I pick the same x values, 3, 8, and 15, okay, what's 3 plus 1 is 4. The square root of 4 is 2. So we're going to have 3, 2. And 8 plus 1 is 9. The square root of 9 is 3. And 15 is plus 1 is 16, and the square root of that is 4. So a couple things already that I want you to notice. You put your input variable in there, and then you evaluate everything that's underneath this radical sign first. Please don't go square root of x plus square root of 1. This is not the same. Okay, whoops, 1. That's not the same. So y does not equal this. So please don't do that. Evaluate everything underneath your root sign, then take the square root of everything underneath the root sign, then do whatever else you need to if it's added out here or whatever. But just don't get caught up in doing this, okay? That's not good. All right. Now, one of the things I didn't really do. What if, in this case, what if x was negative 0. Well, let's just say 0.75. What's the value here? Negative 0.75 plus 1 is positive 0.25. Make sense? So if I took the x value here, negative 0.75, first of all, is this even possible? Can I even do this? I have a negative value and I have a square root. Is that okay? Or is negative 0.75, is that actually in the domain of x here? Yes, because I'm adding 1. So that's going to bring it over into the positive area, okay? Good. I'm glad you noticed that. All right, so negative 0.75 plus 1 we said is 0.25. What's the square root of 0.25? It's 0.5. Okay, that's very good. Now I see I got rid of some of this stuff. What was this, 2 and 3? Okay, now I want you to notice something. This is another thing you want to notice, that most of the time when we take the square root of a number, it gets smaller. Square root of a number, it gets smaller. Square root gets smaller. When we take the square root of a number between 0 and 1, it gets bigger. Okay? So this is actually bigger. So the square root of a number between 0 and 1 is always larger, because you think about it, 0.5 times 0.5 will give us a smaller number than we started off with. 3 times 3 gives us a larger number. 2 times 2 gives us a larger number. Okay? All right. What about negative 1? Negative 1 plus 1 is 0. What about over here? Negative 1. Well, that's negative 1 plus 1 is 0. What's the square root of 0? 0. So that's another thing I want you to remember, that 0 is the same as its square root. Right? Okay. And this is stuff that we probably should have known from the other section, and maybe we did go over that. I actually can't remember. But I'm just kind of confirming some of the stuff. Okay, so I'm going to do one more for you. What about if we have 0, excuse me here, the y value is 1. So 0 over here, 0 plus 1 is 1. The square root of 1 is 1. Ah. So when we have 0 underneath the radical sign, its square root is still 0. When we have 1 underneath the root sign, its square root is still 1. Okay? And of course, the other thing that I should mention is if x provides you with something that is negative underneath the root sign, that does not work, right? You can't take the square root of a negative number. So here, x equals -3, that's a y value of -2. But over here, right, there is no solution. That is undefined, okay? Can't have it, can't be done. It's not part of the domain for that. So remember that whatever is under the square root, this right here, has to be, this has to be greater than or equal to 0. Right? So that's our domain. If you're looking for the domain for a square root function, then set whatever's underneath the root sign greater than or equal to 0 and solve for your x. So that's why this does not work. Okay, more on that later. Let's talk about the graphing. Okay? The graphing. Now, on your graphing calculator, you can be free to graph this on your graphing calculator, or you can just watch carefully up here. Because what I have is I have this line, y equals x plus 1. That's the same one we just kind of took a look at some of the values for. All right, and here's the graph of the line. Okay, so this is going to be interesting. When I also light up here the square root of x plus 1, look what happens. That's the shape of the graph. Now, this blue graph alone, that should look pretty similar to, I don't know, a graph like maybe just square root of x that we talked about in the first section, right? Look at that. That's an identical, it's an identical graph. But what do we know about this root x? How has this been changed because of what we see here? It's been transformed 1 unit to the left. Okay, that is still the same as the last section. But now what we're looking at, and this is very important, now we're looking at the comparison between a function and its square root function. So we're not looking at transformations like slides and stretches so much. We're looking at how is this red graph comparable to the blue graph, its square root. So I want you to notice a couple things, okay? And I'm just going to take a print screen of this, and I'm going to plop it back here. Awesome. Technology is great when it works. I should get a t-shirt. I love technology. When it works. Okay, and right now it's working, so I don't want to jinx it. Alright, so watch this. If we're given the red graph only, right, the red graph only, you know that this is the y value. This is the original y equals f of x, right? And if you were to graph y equals square root f of x, because that's what this function is all about, then you simply, and it's very easy, you take a look at all of the y values of the function, and you take their square root. It doesn't matter what this function is. It doesn't matter. You look at the y value. So look at this. Y equals 4. On the square root function, the y value should be 2. See? You like the sound effects there too? Does that help? Does it help keep you awake? No? Sleeping? Okay. What about 3? Okay? What's the square root of 3, everybody? Oh, I don't know. Let's ask Mr. Calculator. What's the square root of 3, Mr. Calculator? It should be about 1.7. So let's see. Down here, what does that look like? How about 1.7 Thank you very much. Now, I'm going to have to go back to this graph right here so I can just zoom out a little bit. Where's 9? Come on, 9, show up. Oh, whatever. 9 is here. See? 9. See the y value of 9. So on the square root function, this should be a y value of 3. And it is. Okay? Now, what's interesting, though, is right around here at this point and this point. Now, let's put this all together. An invariant point. We have an invariant point right there at y equals 0, 1. Invariant. Remember what that means? That means on the graph and its transformed graph, it's the exact same point. Because y value of 1, what's the square root of 1? 1. Awesome. So that's going to be an invariant point. What about over here? A y value of 0, square root of 0 is 0. Very good. I have a question for you. Why does the blue graph not continue down here? Why does it stop there? Exactly. Very, very good. These negative values down here, look, this is all negative. You cannot square root a negative number, so that means it does not exist down here below. Okay? Now, I have a question for you. What is happening here in this region right here? Why does this look a little wonky here? Is that your question too? Okay, so why does it kind of go up and then back and then underneath? So it's like above the graph. Sorry? If you have 0.5 as the original function, and you take the square root of 0.5, guess what? You're going to get 0.707. And it's actually going to be larger. What did we test? Didn't we test like 0.25 here? Okay, so 0.25, look at that. The square root of 0.25 is 0.5. So, when you're graphing, okay, let's zoom out. Okay, ish. Let's take another print screen here. Technology is awesome when it works. My computer freezes right now. I'm singing a different song. Okay. Making it work. Okay. So, check it out. Check it out. If you're given a graph, this is what you do. If you're given a graph of a square root, you look for the 0 and the 1. The y equals 0, and I'm going to do this in red. Y equals 0 and y equals 1. Those are invariant points, so you put them right on the graph. On every single square root graph. Yeah, actually I should have done the other one. Forget it. Back up the tape here. Back up the tape. I'm going to actually start with the other function. That's what I should have done. Okay. So technology is great when it works, and also teachers are great when they're doing what they're supposed to do. Okay, this is the one that I wanted to start with. Got it? You guys aren't writing this down anyway, so you don't care, right? You're just sitting back there watching a video game here. It's like, feed me. Oh, feed me. Give me stimulus. Give me stimulus. I don't know. You guys, I don't know. That's what you're thinking. I know what you're thinking, okay? And yes, you think in those voices. Feed me. That's what teenage thoughts are like, I know. I think. Okay, so 0 and 1. Let's try this again. I'm going to do this in blue now. 1, the square root of 1 is 1. Thank you. Put a dot there. Square root of 0 is 0. Thank you. Put a dot there. I know I'm not going to go underneath the x-axis. Right? No, the straight line can be underneath the x-axis there. That's no problem. But when you take the square root, you cannot take any square roots of negative numbers, so there's going to be no graph underneath there. Okay? Girls, you paying attention back there? No, you're not. So now you are. Okay. Okay, what else? Go to 4. Look at 4 is a perfect square. What's the square root of 4? 2. Put that number there. What's the square root of 0.5? We said it's about 0.7. So go up there. Look at, we're assembling things. Square root of 3 is 1.73. So you see what we're doing? Roughly, the graph looks like this. You start down here at the 0, and you go above the line and then back to y equals 1. Try that again. Above the line, through that point, back to y equals 1. Then you continue on through the other points that you have plotted, and so on, so on, so forth. There you go. That's your graph. Okay? Got it? Now, here's your turn. All right? I'm going to give you... Oh, yeah. Okay. Y equals negative x plus 1. Looks like this. Okay? Sketch it, and draw me the square root function. Okay? Just sketch this in your book real quick. Goes through 0, 1 and 1, 0, straight line, negative slope. Okay? I'm going to pause here, and I'm going to... This is going to be easy. All right, pretty easy, right? Should look like this. You locate your y equals 1, your y equals 0. Do a little bubble on top of the original line, and then kind of continue on. You might want to label a point or two. There's 4, there's 2. Go over to 9 and 3. Go up to 16 if you have it, down to 4, and so on. Connect those with a smooth point. Okay? All right, now let's get to something a little bit more complicated. Any questions about that? 1, 2, 3, going, gone, gone. Okay. What if you have something like, not just a straight line? So let's say you're saying, Mr. Maxwell, that's all well and dandy, but what about x minus 2 squared? Yeah, like, oh my goodness. Okay, what's it going to look like? Y equals the square root of x minus 2 squared. Oh. It's going to be what? Oh, it's going to be a line because the square and the square root cancel? Okay, who else thinks that? Lots of hands in the room. All right, well, let's just test that. Why don't you go and get on your calculator right there, jump right on it, turn it on. That's the on button. No spelled backwards. Y equals, clear everything that's on there. Go ahead and graph it, and we'll see. Oh, burn. Burn. Not a straight line. Oh, we forgot about the whole negative thing. Well, look at this is not a straight line. Look at the green line. It does not continue on through to the negative because you can't take the square root of a negative. Ouch. So guess what? Guess what we got to do? This is pretty close, but it's actually y equals absolute value x minus 2. That's what it is. So you're close. Good job. Nice work. Close, but no cigar. You guys, did anyone ever say that to you when you were young? Close, but no cigar. I have no idea what that means. Somebody said that to me when I was little. I don't know why you get a cigar if you're, I don't know if you win, if you're right on the money. I don't know. Anyways, close only counts in hand grenades and horseshoes. You ever hear that one? Yeah, you heard that one? Okay. Anyways, it does apply here. Okay, but now let's just check something out here. Notice, okay, if I zoom in here, just to these important points, 1 and 0 are the same, right? 1 and 0 are the same. And this is a bit of a strange case here. I will admit, okay, but it's only because this is all squared and then square root. Okay, so we're going to do other examples here, but in this case, yes, where you would normally get a line where this exactly cancels off with this, and you're left with x minus 2, which looks like a line. You have to remember that it's absolute value. Okay, so the y equals 1, 0 equals 0. Those are the same. And because this sort of dips down, guess what? It makes a straight line there. See? One's a straight line. One sort of is like a little bit of a bubble there. Okay? Now, let's just say we have an example where it doesn't look exactly like this, and you wouldn't have x minus 2 just as your answer. So what I'm saying is, let's talk about something like, actually, I'm just going to change this. Or just X it out. So, type this in your calculators with me. Ready? X squared, let's say plus 2x minus 3. Let's see. Oh, that's beauty. That is beauty right there. That's exactly what I'm looking for. Okay. It's going to be a little bit tight to see, but we'll be able to do it. Okay? So let's say we have this one. Now, let's say that we have the square root. Can I copy this? Copy. Paste. Perfect. Look at this. Whoa. It looks like some African animal or something. Like it's what's that African animal that has kind of the big horns? A water buffalo? No, not a water buffalo. That's not the one I'm thinking of. Gazelle, maybe? Sort of like a gazelle. What's the one with the curly horns there? What's that one called? Antelope? No. Oh, it's on the tip of my tongue anyways. Ram? Ram. Ram? Okay, this is what I'm talking about. Look at. This is what I'm talking about. Let me just put this on here. Okay. Look at. This is what I'm talking about. Look at. This is the one I'm talking about right here. You know, like the
A reindeer.
reindeer. Yeah. I don't know. Rudolph. Yeah, it does kind of look like a kangaroo. Okay, what's the one with the curly? I'm a little off topic here. No, it's not a ram.
It's the one with
No, it's not. It's blonde. It's like yellow and black and white. I want to say Lorax, but it's not the Lorax. That's some fictional character. Okay, I will have it. It's on the tip of my tongue. This is your brain break, okay? This is your brain break. It's not a ram. No, I'm not looking it up right now. I've already spent too much time. Okay, pay attention. All right. Okay, let's bring it back down. Okay, check it out though. Anything that's negative, the the square root function does not exist down here. See that? Anything that's below the x-axis. Okay, awesome. 0 is 0. 1, there's 1. 1 is 1. Okay, and we have a little bit of a bubble out, back to 1, and then these kind of just fan out like that. So in general, whoops. In general, you see kind of what's going on here, right? And it's the same thing. 0, 1. Okay, bubble out, it's greater. And then go ahead, where's 4? 2, 3, 4. So 4 is going to be 2. There's going to be 4 up there. There's going to be 2 there. See that? You're going to have 9 on the original one. This is going to be now 3 right there. So on. So then you connect points out. Okay, how do you know what? Well, you look at the original yellow graph here and the x values. This one doesn't matter really what the x values are actually. You're only looking at the y values. Because remember, here's the function here, and then we're taking the square root of that y. That's y. That's all this is y. This is y, this is y. So it doesn't matter what the x values are. You can find the x values, if you want, you can find the root here. Right? Let this all equal 0 and find out what x is. But I'm just kind of showing you what it looks like for any graph, and parabola in specifically. Okay? All right. So, I guess that's where we'll stop today. I am just going to kind of show the key points to the lesson here. And I would like you to do number 3. Number 3 before tomorrow. That's just matching number 3, okay? 2.2, and we'll continue tomorrow. Number 3, matching. Okay, what's your question?
So number 6,
Mm-hmm.
get the A. So is this question asking me to translate from here to here?
No, from here to here. So what transformations were applied to this to make this?
Okay,
Got it?
so
Awesome. You bet.